Hey, Rani here. Shall we make a game? So last time we got this working to the point at which you can click anywhere and a guy kind of walks towards it and falls over, and you can even make him go around corners. Now at the moment his kind of movement is kind of juddery, it's not great, so we want to kind of fix that. So if I draw roughly what's happening here. So what's currently happening is if we say got like a nav mesh tile like this. At the moment, there's nothing built in to really tell you the best way to get from a point to an edge. So we know we want to cross this edge. There's nothing built in at the moment to actually kind of do that. So the complexity comes in when you have, like, say, let's go for a really complex shape like this. It's still convex, but it's complex shape. You got to show this, and you're stood here, and we need to get you to over this edge. Well, whereas in say something simple like a triangle, you could basically just walk in the direction of the that you'd have to walk to exit the polygon. If you tried that here, you'd end up crossing the wrong edge. So what we need to do is we need to write a function that checks if walking in that direction will get you over that edge. If so, return that direction. Otherwise, it needs to detect that collision and instead, I don't know, maybe aim you towards the midpoint or maybe the closest point on the line or something like that. That'll do anyway. So yeah, actually thinking about it, there's actually a really simple way of doing that. I was about to go, oh yeah, we do like collision checks for the walls. We actually don't, because all we really need to do, if I just undo all the scribbles I just drew, hope the undo buffer's long enough. Yeah, what we actually need to do is we need to take whichever point you're at, project it onto the plane of this, right? So we figure out where, imagine this edge was kind of like infinitely sized. And then we just check whether it's within this range. In fact, we just clamp that position to within that range and then walk towards it, because it doesn't matter where you are, you can always get to it. And it'll also find the quickest route to that edge. Huh, that's actually quite a nice solution. So I guess I get started on that. Navigation mesh. And we can do that quite easily, given we now have the ability to normalize a vector. Actually, something I was going to do to that, something I was thinking about, is at the moment you have this thing where kind of like, oh yeah, behavior is undefined when input is 0 length. What I might do actually is make it so it returns the length of the vector. And the reason is that allows you to, in cases where you need both the length and the normal direction, it means that you have both from one call. You don't have to calculate it twice. The magnitude of the input vector. And we can say it will not be modified. Be modified when the magnitude of the input vector is, 0. So that if you're, say, drawing a line from a point to itself, it won't try and normalize that. That makes no sense. And it'll return 0 so you can tell. And I'll also make this do the same thing. That'd be handy. Will not be modified when origin and destination are equal. Okay, there we go. Get rid of that. Return the distance between the origin and destination. Okay, that's going to be handy. That'll be a bit strange. I've never seen any math library do that, but I was thinking that'd be so useful in so many situations. Yeah, where I'd actually be using this. So yeah, here's our magnitude check. If magnitude, I think that's all you have to do. I mean, for integers, it definitely is. Let's check here. Float C truthy. I know that an integer that isn't 0 counts, but would say 0.1 count. If C numeric What's it do? Anything that's not 0 is a true value in if. Does that include floats though? That definitely includes int. Yeah, it's probably true. Okay, if it's not, we'll probably find out. And then we just return the magnitude here. Simple. And... aha. And the other thing I was thinking was, in our matrix kind of thing over here, we have the matrix look at. I was considering actually redesigning this and splitting it into two functions, one of which you give it the normal. Yeah, rather than it calculates the normal, you instead give it a normal. And one way with this current, yeah, so I guess it'd be kind of look between rather than look at. And I've kind of got this thing here where I'm kind of like overloading names. So I've got like destination, which in the case of like this is like origin destination. I have to think about that. Maybe maybe rather than destination, I use like matrix pair or something. I'm not sure. I'm not really a fan of like naming things the same as types because, well, you've already got the type name, but who knows? Okay. And let's do the same thing, but here, and then one of them's just going to call the other. Calculates the 4x formation, which looks along a normal from along a unit vector. Unit vector indicating the object's forward direction. It's z minus axis. Actually, yeah, I should probably clarify in that other comment and say it should be the y plus. Okay, that's nice. I like that. And actually, I'm going to get rid of this. I actually much prefer this because I mean, like, you can always do that calculation outside. It's not really a complex calculation. And there's the edge case of, well, what happens if the start and the end are the same? You don't have to think about that at all if the normal's been passed in. I don't think we need to normalize that at all. We've already said that as part of the contract, the thing for passing in has to be normalized. I call it forward in some places, normal in others. Okay. All right. Okay. Yeah, I've still got to write the inverse matrix. Actually, that's not going to be super hard to do. It's going to be the transpose of it, which is going to be... hang on, it's too early for this. Yeah, I think it's going to be that. Actually, I can have a look up in here. I've got a bit for the kind of... yeah, I've got this here where I'm actually doing the inverse of what's above. And I kind of end up doing that, which I'm sure is right. Okay. This is probably right. I won't bother testing it yet. We'll figure it out some other time. It'll end up being used eventually. Ah, it's 2 7s. I was just a bit confused and the pattern didn't quite match up because I didn't overwrite one of the items when I was moving through that. Okay, next up we've got the forward normal, which is just called forward because it's already a normal. Oops. And there's one more thing we need to do, which is the scaling. Which again, I don't think we're going to test that right now. So I'm pretty sure it's been a while since I've looked at this part of the code. Okay, right. The scale goes like ABC, ABC, ABC. Okay, got it. Yeah, I'm sure rushing this part of the code and not testing it won't come to bite me back in the ass later. That never happens. Okay, that's the scale and the inverse done, and destination is done. And I'm gonna get rid of that because, yeah, it turns out some of these need to be transposed, so you can't actually just write direct to the matrix. Okay. Oh yeah, another thing. If you're going to calculate the inverse, actually, store it in the inverse. Don't store it in the forward part. Oops. This is going to break a few things because I have just removed a function I was definitely using in at least one place. Yep, there it is. And it's all chewed up. Right, so this is the... Oh yeah, I should write that function I was going to write that was calculates the kind of normal that you should be following. Yeah, I've got a few things to kind of sort out before I can do this, and I'm kind of like jumping between them a bit quick. Okay, so do we have vectors in here? Do we have vectors? We brought them. Hey, how's it going? This morning, so at the moment we've got to the point at which you can kind of click on a point in the map and the guy will kind of navigate to it. But at the moment, as you can see, he's having a few problems. There's no walk animation. His kind of like movement is kind of erratic. Such as this is very erratic. And he kind of falls over as he approaches his destination. So I'm basically trying to fix all of that and get to the point at which he's kind of like moving well. At which point we can then sort of like start placing more objects, get rid of some of this overlay, and start actually making the scene work as a kind of point and click adventure section, which was meant to be what the whole game was supposed to be, and we're only like 8 days until the end. Okay. I'll bring in the vector header. I think that ends up being brought in by accident by the matrix header. Okay, so we're going to calculate a vector. Actually, it's not going to return it. We're going to give it one to overwrite. What's a good name for this? Anyway, so this function, when we call it, calculates the unit vector along which There will be no crunch. There will just be a. Let's go for a whimper, not a bang. Calculate the unit vector along which an entity should travel to reach a specific edge of a navigation mesh face. So we're going to pass in a navigation mesh to compare to. Oh, sorry, the navigation mesh containing. I can't spell. And we've got our face number, the index of the face containing the entity. And we're going to need the location. Location of the entity in the. I can't spell. Location meshes local space. And then we have a parameter for normal. Overwritten with the unit vector along which. Oh, I haven't put in the parameter for which edge you're actually approaching. The index of the edge of the face within the navigation mesh, which that's shortness, which the entity seeks to cross. Okay, that's good. That'll do. Navigation mesh, we've got our face, we've got our edge, we've got our constant vector. Yep. And then we've got our non-constant output vector. So okay, onwards to the implementation. So this file's getting quite big. That's fine. It does important things. Wait, is this actually playing the same song again? Oh, I guess I just have 2 copies of that song for some reason. Okay. Yeah, so in this case, what we're doing here is, let's draw this up again. We're here, we're looking to basically find the correct point on this edge we want to travel to. It's going to be the nearest point, so we need to project this point onto that edge first of all. So or do we actually? No, we actually want to get the difference between there and there, dot product it with that edge coefficient we had earlier. I'm going to be using that again. That ends up having quite a few usages. That will get us the, let's get a value where one end is north and the other end is 1. We can then linearly interpolate between 2 vertices. So we're going to need the vertex location. We're going to need the vertex count, so we need to know whether to wrap around. We need to know if we've got the last vertex, whether we need to wrap around to the first to get the second one. We need the exit normal. We do need the edge coefficients. I'll grab that in a second. Edge coefficients. And will it let me do this? Probably not. So we're going to have a constant for this. So we're only looking at one face, so we're not going to bother taking reference to the whole array. Okay, and then we have our vertex locations. We're going to use 2 of those. So actually, we can get the vertex locations for the current face. That'd be a good idea. We don't need the exit normals at all, actually. We only need the edge coefficients. Okay, that should work. And then we need to do a dot product. Oh, we need to do a difference as well. Yeah. Oh, just thought actually a nice kind of like handle we could do for this. If it ends up being that we're already on the edge, we can just give it the exit normal. So maybe we do need the exit normals, but only in one special case. So I'll leave that out for now. So don't go blank, don't go blank, don't go blank. Okay, difference to first vertex. And then we're going to do a subtraction. We then dot product that with the edge coefficient. We spell it correctly, that helps too. Okay, that gives us our position along the edge between 0 and 1. We then clamp that. Now, my clamp thing, my sort of clamp helper is, it does pre-process a macro, which means it might end up calculating like this value more than once if we're not careful. So I'm just going to store that in a variable unclamp progress. And I'm going to have a clamp progress. I should probably fix that. I mean, how often do you actually need to clamp something at like a pre-process level? You don't need to do that very often. Okay, we're good there. And we then actually we can just reuse this this vector. We don't need to keep it kind of like here clean. We can use it as an output now. So then I'm going to do a linear interpolate from the first location to the second location using that unclamp progress. Actually, I can be really cheeky. I can actually use it as the use it as a temporary variable here as well. That's really cheeky. Don't do that. And the 3 axes and writing the result to the normal. And then we get the, oh, hang on. The normal might be the location. So I can't do that. I do actually need to keep a temporary variable. So yeah, we need to, oh, we can also return the distance out of this. That'd be really handy. Oh, the what? The firstance? What's that even mean? Let's come up with a new word. The location of the entity and the... Oh, maybe this should... Oh, hang on. This should actually return the closest point. It shouldn't be returning the normal. Closest point. Oh, but it should be returning the null because that means that if it reached the edge, it can push you through the it can push you over the edge. Okay, distance between the location of the entity and the closest point and the closest point on the specified edge. Maybe 0. So we went from the location to the temporary variable, which is our point on the line. And we're going to output it to the normal. And we're going to get our distance out here. And if the distance is 0, that's when we copy the edge exit thing. Yes, this is basically if we're kind of like really close to this line and it looks like we're, we don't have like a clear direction to it, then just go, well, just take the kind of exit normally be crossing anyway. Use that as your exit. Okay, we can now go through this script over here and there's a bit in here where I'm like trying to right, that's right, yeah. Here it is, yeah. Here's the bit where I'm like doing the midpoint stuff here. We don't need to do any of this anymore. So we've got a root, and all we need to do now is normal to edge. And we overwrite the next with the hang on, we're gonna need normal. Sorry, I'm just we'll figure it out. We'll figure it out. So we're passing into this. We have the navigation mesh. We have the face that we're on. We have the edge that we're trying to cross. Then we have the current location, and then we have the normal that we're going to overwrite. And then we multiply, oops, not the matrix. We multiply our normal by a fixed speed, let's say that fast, that many meters per frame, and then 3 axes, multiply normal, and then we just add that to the previous location to get the next location. All of this can just get out of here. Why did they put like matrix in videos? It's just a strange place to put it. It's clearly a math thing. Anyway. Oh, it didn't like that. Oh, I think I made some of these constant in one place and not the other. No, it's not that. Oh, I never told this end it was going to be returning a number. And we need to multiply these by 3 as they have 3 axes. Okay. Still encountering compile bugs. And these shouldn't be edge coefficients, they should be exit normals. Unused variable. Oh yeah, I'm using the unclamped rather than clamp progress. Okay. Right. This will still look kind of jank, but if I'm right, it should. Oh, if it doesn't crash the console first, it should result in some motion that doesn't get stuck on things all the time, and kind of doesn't like pause the edges because it won't be waiting to cross them anymore. It won't be doing that thing where it kind of like because I was doing kind of like a sort of like a friction kind of damping thing to kind of pull the character towards edges. I didn't do a parallel build. Why not? Build. Build. Okay, let's give this a go. Oh my goodness me. Yeah, that isn't working. 1 second, I'm just taking a screenshot of that. Oh man. He's not falling over anymore. You're right about that. He's having other problems. He's he's oh, what's the painting with like the painting with a skull at an angle? This one. It looks like that. Okay. So I think I know what I broke. The question is, what did I break? Let's comment all this out, because it might be in there. Next up, let's last thing I did was add scale to this, so I probably broke something in the process of trying to do that. Those scales are actually backwards, they should be divided, not multiplied. Because we're kind of reversing the transform. Okay, I'm not using scale, that's fine. It's intentional. Wait, I think I know what it is. I know what it is. The number I'm passing in isn't a normal, I don't think. I mean, it's definitely not normal what you're seeing. Okay, to do, let's check this. I know I've made a mistake here. I know I've made a mistake. So XX is, yeah, it should be divided by, yeah, these should be divided by scale. And we're not scaling the transform that way. This will only ever really be used if you're applying this to a camera, which, to be fair, it's definitely possible. Right, so I've got a bit in here where it's doing the look along. And we've got, yes, I'm actually giving it the position as a forward vector, which is not right. So what I'm going to do is I'm going to add a forward vector in here, so just so it's got like a record, so that if the guy stops moving, it remembers which way he was facing, pretty much. Get rid of that. Okay, and then we're going to overwrite that. We're going to initialize this as something practical, like say 1. That should make him face the camera. And then just find the bit where it actually, there we go. Right, there we go. That's probably right. Ah! Now the other thing that's happening there is that when he has direct line of sight, it goes into like a special code path where he stops like looking at the nav mesh and goes, I don't need to, cross these tiles, I can go to the straight line. So I need to change this to also calculate kind of like a normal. So in fact, this just needs to get the normal between. This can return 0. So I'm just going to have to put this into a temporary variable and then copy it down. Okay, so the next thing we need to do is the normal between. And okay. That's kind of annoying. This bit of code here kind of needs to be the same. Maybe we should put a flag in here saying like moving. Next thing we need to do is we need to start thinking about how things like animation are going to work. Because we need to be playing like walking animations, always walking and things like that, but not when he's not walking. So if the distance between is, say, let's make it so it's 0.1, something like that. That's when we're going to copy that over from the temporary variable we just made to the forwards. It's just so this is just so it doesn't like overwrite his forward direction if it's only like a very small kind of influence he has. Okay, does that work? Oh my. So yeah, he's kind of taking the sort of shortest route here. Oh, but he's not having a good time once he gets line of sight, so there's something wrong there. Previous target. Then that right to the temporary. What's going on here? Why isn't that working? Okay, is it definitely hitting this? That's the next question. Wait, no, it needs to be if he's further away. Not if he's closer than 10 centimeters. If he's further away than 10 centimeters, then he needs to start walking. Okay. Might speed him up a bit, but that looks like it's working. Okay. Hey. I can send him around to here and he'll follow it. Oh, it's working. Oh, it's good. Okay, so that means I should be able to, like, say, click on, oh, the popcorn won't work because it's not actually, I've not got the same script on it that sets the target location. I should be able to say, click here, and he'll walk around to the closest thing he can find on the nav mesh that will... Yes, that's kind of how you expect the adventure game to work, right? Oh, and then he kind of just takes off. Should have considered that, really. Okay, I'm going to need to do on this stat. To do lock to nav mesh surface. That'll do. I know what I meant by that. Next thing we need to do is have a static variable for whether it's moving or not, and then we compare that, and that's how we know. This is how we know whether or not to play an animation. We could also, if I was seeing audio for this, we could also like set up like audio cues and stuff. Okay, so it should be a... Do I remember what this is? Play animation? Set animation? There it is. And it's going to be the protagonist. And then we're going to play the standing animation. And we don't care about what happens when that animation finishes. Just don't tell us. Just play it again. And then we're going to play his walking animation if he's currently walking. Oh yeah, and I actually need to make a record of that as well. Otherwise it'd think it'd be a new animation each time. Hey, that kind of works. He's a bit slow, but you gotta remember these sets are gonna be really small. Oh! Oh, that's unfortunate. Okay, that's a thing that can happen. Oh, he got that eventually. Good for him. I wonder what's causing that. Seems to be when he's like close to an edge. Again, I can tell him to like sort of go there and he'll go as close as he can. Oh my, it's just it's not going well for him at all. So I've got an idea of what might be happening. I think I can reproduce it by sending him there and then tell him to go there, right? Yeah. The question is, why is he going left? I think I know why it is. I think I know where it is, and to solve this, we need to hang on a second. I'm thinking. Ow. We need to calculate the distance to the surface, and if he's over it, so let me just explain what's happening here. So you've got, like, say, the edge of your polygon here, and let's say that he's actually very slightly outside it. So what's happening is it's going, well, the closest point on the line is like here. So despite the fact he's actually outside, he actually needs to walk back into it. It's just like a numerical precision thing. So I guess the way I could resolve this is to detect that he's already over the line. In which case, just carry on, sir. Just carry on. So I already have the difference, so now I can grab the edge exit normal here. Oops. And then we can dot product the temporary variable with the exit normal. It's 3 axes. And if it's greater than or equal to 0, then he's kind of already over the edge, in which case we just tell him, keep going that way, champ, you're doing great. just keep going in the sort of like default direction of that edge, you'll be fine. Yeah! Take that, bug. Let's just try a few more extreme examples. Let's get him to like push into the wall on the way down. Yes! Happy with that, happy with that. Right, so let's start committing all these smaller functions we've written. Yep, those are good. Those are good to go in. This one. I've got some fixes I need to make on it. And I will actually test them, I swear. Okay, so we're going to need the inverse of the scale, which is going to be... Oh, what am I doing? Oh. Oh, I see. This actually has to be its own thing. Yeah, I can't use the like reciprocal trick here. Divides 1. Is there a good term for like the difference versus the sum and sum? Yeah, difference product sum. What do you call what do you call the result of a division? Don't know. Divides a scalar. Damn it, learn to type by a vector. And when we're doing the length thing, I'm going to be using fixed length vectors. Oops. And, oh, hang on, this should be divide scalar vector. There we go. And this is going to be very simple. It's going to be yeah. Just took me a second. It's going to be very simple, but it still took me a second to get my brain around it. Man, I'm looking forward to a bit of a rest from all this programming, to be honest. Spoiler: there will be not much of a rest from this programming. There will be a rest, but not much of one. So we actually want to reuse these instead of like trying to calculate the contents. We want to reuse them so that way we're getting the scale factor kind of factor into them. Not really sure how I'd test these short of sticking a camera on his face, which I'm not above doing. Okay, that should work. Oh, I changed the header file, need to rebuild. And here's a scenario, and it should look the same right now, but I'm going to apply some scale to them and see if it applies correctly. So yeah, that seems to be working. So the next thing is test it out with some scale. So let's make him twice as wide. And yep, that seems to be working correctly. It seems to be kind of like carrying that scale around properly. Very good. I don't really have a means to test the inverse matrix without doing a lot of work. It'll be useful in later projects. I'll test it then. Add look along function. Don't need that. Oh yeah, I should have checked that in as well. Add vector division. What else do we have? Ah yeah, add to edge function. Okay, what do we have in here? What is this in here? Oh, this is when I was debugging selection. Get rid of that. It's no problem. Get rid of this debug stuff as well. I guess we can get rid of all this debug stuff in here as well. We don't really need to that stuff on the screen anymore. And we don't really need to be able to see the nav mesh. Let's see how it looks without it. So make sure it kind of like still sort of makes sense when you can't see it. You just kind of tell them where to go and it kind of goes there. I might speed them up a bit, just a bit, because as much as this is probably quite a realistic speed, it's kind of annoying. Okay, so the next thing is I need to start thinking about making objects interactive, like this here. It's going to be something you can click on. He's going to walk over to it, and then there's going to be a specific action when you reach it, but not when you click on the background. I can describe just how kind of like neat it is to see all this actually working. Oh! Why did I say that? Why did I say it? Why did I say it? Okay, I think I know what's happening. Because he's trying to go up, he's trying to leave the nav mesh, so I need to basically clamp the point onto the nav mesh so he doesn't try and leave. So there should be a bit in here where where is it? Static click, here it is. Should be a bit in here somewhere where I'm getting the closest right, yeah, I need to clamp the location of the target to the surface, so constrain to surface, there we go. That should mean that he no longer tries to leave the planet to get to a point. So yeah, that's it. There you go. It's basically like also previously when he reached the wall and the target was over it, he would keep kind of walking into it as though he's trying to get through the wall to reach it. He's not going to do that. Okay, let's speed him up next. I'm thinking let's give him a 50% boost. So okay, just make sure that isn't like completely unreasonable. Yeah, that's probably about as fast as you expect. The other thing is you have the thing in like a lot of adventure games where you can double click to go faster, right? I don't currently have anything in this engine to do double click, but I could just count the number of frames since you last clicked and just count as double click if you click twice quickly. So let's do that. Yeah, I'm gonna need like some game specific stuff in here pretty soon. So let's have the type for this. I guess this will probably go in characters if I have a, yeah, in here. And let's grab this and put it in here and then turn it into a character motion state. This is not kind of like general sort of engine code. This is something that's very specific to this game, so this won't be coming over with the engine rework. Describes the state of a character. The character is not moving. The character is moving slowly. The character is moving quickly. Oh, I nearly wrote ruining then. No. I'm the one ruining things around here. Right. So rather than this moving thing, we're going to have a character state. I'm going to have to import that. Now, I might end up adding a component specifically for characters who can sort of move around the grid because I don't want to have to copy paste this code between every scenario. We'll figure it out. I can record in here. I'm going to need a thing to count the number of frames since last time you clicked. How's that going to work? You know, maybe it should actually be a part of the selectable thing. Oh man, adding that's going to like... Yeah, I'm going to do it. Am I going to do it? No, I'm not going to do it here. I'm not going to do it here. This has had almost no usage outside of this. Oh, do I put an advanced component on just to measure this? I guess I do. Oh, no, wait. I have timer components specifically for this. Why don't I just use one? Yeah, I do. I have timer components specifically to handle this kind of thing. And the only thing the double click timer really do when it kind of times out is it would clear its own kind of reference. So anything it takes in is one of those, that's good. Right. Man, I normally go for more than an hour on weekends. I'm making good progress, but I'm really starting to feel the kind of yeah, the fatigue hitting. Okay, so in here we need to check if there is a double click timer. And what we're attaching this to, we'll attach it to the protagonist. And it's not going to have a parent. Although if we did make like a character component, it would be that. Don't pass in any metadata. We don't care about every frame, we don't need that. And when it expires, that's when that goes into there. How many frames are you going to allow? Let's allow 30. It's half a second, that's long enough. It's going to be static. Character state is character state. Walking, there we go, yep. Whereas at that point, we destroy the component. And then we reset that reference to it to none, to mark that we don't have a time running. Okay, that should be good. Oh yeah, we also need to play the right animation here. And there's no different animation yet, but there will be later on, I think. And I don't think we need to, yeah, we don't need to track this anymore. Oh, we do. Okay, we need some roots in here that tell it to stop walking in certain situations, but otherwise to keep walking. Other than that, it'll retain its previous state, which is good. Next character state. Okay, that's good. And then if the character state's changed, That's when we play the idle animation, otherwise we're doing nothing. Actually, this should be a switch, not a just not an F, because we're gonna have 3 states here. We're gonna have. Hang on, my brain. Okay. Yeah, I'm probably gonna stop as soon as I get this working because I am really feeling it. Let's not go to quite the 2 times speed. Let's go to like just under. Oh yeah, I changed the header file, didn't I? Damn it. And this is expecting a block. That's fine. And we need to tell it that's fine, that we're not using that. I changed the header file. Why am I doing a serial build? Do a parallel build. So I should probably. Wait, hang on a second. I'm just reading this again. What am I doing here? That's this bit I was looking for. I was confusing for a second. Right, okay. So what I was thinking was, what if instead I set the speed in here and then use it in a shared bit of code? That allows me to cut down some duplication. And also means those blocks aren't necessary. There, that's a big improvement. That's way shorter, way simpler. Well, done that simpler. That's the what's the term? Cyclomatic complexity. It's probably higher. Okay, that double click isn't working right now. Oh, and the engine crashed. Great. Okay, next step we need to figure out. Why isn't he speeding up? So let's just check in here. So if we don't have a double click timer, which we won't, then create one. Yep, that's fine. Put them into the walking state, play the walking animation. However, if we do have a double click timer, let's put an IE error in here and see if we're hitting this. Basically, it's going to crash the engine when it hits this block if it's hitting that block. So yeah, it's not detecting that. Why not? I'm definitely recording it. Is it definitely hitting this block? It should be. Yep, it's definitely hitting that block. So we definitely should be getting a timer out. Is it hitting this somehow? That wouldn't make any sense, but let's have a look. Okay, it's definitely hitting that, but it's not... It's hitting that at the time you'd expect, which is like half a second after clicking. But then this code down here just doesn't seem to be able to see that. It's weird. Oh, I know what's happening, and it's kind of dumb, I think. Yeah, right, so what was happening was, I was clicking on this cube and not on the background. So it wasn't counting as a double click. Okay, that's good. I'm gonna get rid of the dummy cube. Actually, you know what? I'm gonna stop there. Like I said, I was gonna stop there. Yeah, so that's all the really good progress. Thank you very much for watching, and have a great Sunday.